Hello everyone. In the previous video, we discussed mesh analysis applied for simple circuits with just voltage source alone. So let me quickly summarize the steps we followed to solve a circuit using mesh analysis. The first step was to identify the number of meshes and assume the mesh currents. And then based on the direction of mesh current, we assign polarity for all passive elements. So I believe you remember the passive elements. The passive elements are the resistor, inductor, and capacitor. We don't have sources coming under the passive elements. And then we split the page into two equal halves and apply KVL to every mesh. And we write the voltage equation. Solving those voltage equations, we get the value of mesh current. So solving the voltage equation, we have the mesh current, and then I want you to go back, read the problem statement, and get the answer for the problem statement. So now, in this session, let me introduce you to a circuit where we have a current source at the periphery of your circuit or at the circumference of the circuit. So I would like to categorize every circuit that you're going to see into three types. So first type is where you have only voltage sources. And the second type is where you have current source located at the periphery. Okay. So or located at the circumference. Circumference of the circuit. And third is the type of circuit which has a current source which is there somewhere in between, like between two meshes. You have a current source. Okay, so that comes as the third type. So the third type is the circuit with current source common to two meshes. So here we have the concept of super mesh coming in, which will be explained in the next video. So now over to the circuit. So as you could see here, there are three meshes and the mesh current is already given in the problem. So we take into account the direction of current, which is already given in the problem statement. And now the problem is to find the voltage across the current source. So we are supposed to find the voltage across the current source. Always remember, whenever you have a current source, the voltage across the current source is an unknown till you solve the complete problem. And similarly, the amount of current that comes out of the voltage source is a mystery till you solve the complete problem. So now let us solve this problem and find the value of voltage that you have across the 2 ampere current source. So now the first step is already completed for us. So let me go to the second step based on the current direction. So current direction is already given. So based on the current direction, let us assume the polarity. So current enters this point, so it is plus, and current leaves this point, so it is minus. And then current enters here plus, current leaves minus. So you assign polarity for all the passive elements. And now over to the second mesh. So again here current enters. Okay, so current is going to go in this direction. So current enters plus, leaves minus, enters plus, leaves minus, and then again it enters and leaves here. So plus and minus. Over to the next mesh. So here you have the current source. Current is flowing in this direction, but you have a current source. You are not supposed to assign polarity to the sources. So you don't assign polarity here. Instead, you go here and put a plus because the current enters this point and current leaves this element at this point, so put a minus. Okay, now let me apply KVL. So applying KVL to mesh 1. So now applying KVL to mesh 1. So remember to take a walk along the mesh. So we'll fix a starting point. So from this point, I'm going to start. So from this point, when I start, okay, so beforehand, let me split the equal to sign and I split the page into 2. One is plus to minus and the other is minus to plus. And I have an equal to sign in between. So let me start with the first mesh. So here, as you see, you're going to rotate in this direction, or you're going to walk in this direction and you're going to write the voltages as you see. So starting from this point, I travel from minus to plus. So minus to plus, I see a voltage of 2. So minus to plus, okay, so minus to plus, I see a voltage of 2. And then I proceed. So I have crossed this voltage source. Now I travel from plus to minus, and the value of voltage drop across this 2 ohm resistor is I into R, where current is I1. So it is 2 into I1. So here I have a voltage drop 2 into I1, and I see this drop when I travel from plus to minus. So here plus to minus, I write 2I1 plus, okay, so I have crossed, and now I again travel from plus to minus. When I travel from plus to minus, the drop in 3 ohm resistor is caused by 2 currents. So here in this 3 ohm resistor, I have 2 currents, I1 and I2. So if you see here, so if you see here, 3 into I1 minus I2. There are different polarities, right? So 3 into I1 minus I2. 3 into I1 minus I2. So I have now completed and I am now reaching the starting point. Okay, so I have completed my cycle. So this, after simplification, will be the first equation. And then let us apply KVL to mesh 2. So here, when you write KVL, okay, so you're going to start from some random point. So let this be the random point, okay. So let me start to move in the direction, in this direction. So I walk along mesh 2, okay. So you're going to walk within mesh 2. So first I cross from plus to minus and I see a voltage drop of 3 into I2 minus I1. So whenever you write, if you're going to write the equation for mesh 1, I1 should be written first, followed by the other current which is flowing in the resistor. So similarly, now I write equation for mesh 2, right? So I have to write I2 first, followed by the other current which is flowing in the resistor, if at all, if you have any other current. Okay, so here it is 3 into I2 minus I1. Okay, here you have different signs, take a note. And then after you cross this element, you come to 1 ohm resistor and you travel from plus to minus. Okay, remember this is our direction of rotation. So I travel from plus to minus. So the voltage drop here is 1 into I2. As you could see here in this resistor, only one current flows and that current is I2. So it is here 1 into I2. And then again you travel from plus to minus and the voltage drop across 5 ohm resistor is plus 5 into I2. You have one more current, right? So what is the other current? It is I3. What about I3? I3 is in the opposite direction. So 5 into I2 minus I3. I3. Okay. So I have completed my rotation. I didn't see any voltage that is from minus to plus. So across the equal to sign, I write 0. So this is the second equation. After simplifying, you'll get the second equation. And then finally apply KVL to mesh 3. So now let me have a look here. So this is mesh 3. So when I write KVL, it means I'm writing the voltage equation. That is, I'm supposed to write the voltage across every element. So 2 into I1 is the voltage is across this 2 ohm resistor. Right? Similarly, whatever term you have in this equation corresponds to voltage. Now, when I take a walk along mesh 3, the voltage across this element is 5 into I3 minus I2. We know that. But I said earlier, the voltage across a current source is a mystery till I solve the circuit, right? So it is not possible for me to apply KVL to mesh 3 because of this current source, and hence I have taken such circuits as a special case. Okay, so now let us see what we have to do. Okay, so now let me just draw this portion separately. Okay, so here you have a current source. It is said it is giving a current 2 ampere, and according to my assumption here, I assume a current I3. So can you guess what it is? Yes. Here I say I assume a current I3, that is true, and again I say 2 ampere current is coming out of this current source. Even that's true. So if you have to relate these two, then you could say that I3 is equal to minus 2 ampere. So that's going to be our third equation. Okay, so this is like a person standing along the road. Okay, one person says that I find two vehicles moving in this road. Okay, and the next person says, I see two cars. Okay, so this person says two vehicles. So both of them are telling the truth, right? We know that two vehicles, in the sense this person is being very, very generic, and this person tells that to be more specific. Okay, so it is understood that I3 we call a generic current. We have assumed a generic current generally as I3, and in specific it is seen that 2 ampere is coming out of this current source. So coming out, and I3 is in the opposite direction. So I write a minus sign. Okay, so I have a minus sign. So now again, three meshes, we have three equations. Solving these three equations, we will have the solution. So let me quickly give you the answer that you have after solving. So it is I1 is equal to minus 0.33 ampere. And then I2 is equal to, so it is clear that whatever current that is seen is not the actual direction of current. Okay, so I2 is found to be minus 1.22 ampere. So let me again redraw the circuit. So So it could be seen that here in this circuit, okay, so this is the given direction, right? So this is not the direction of current. This is going to be the actual direction of current. Okay, so here you have I3 to be equal to 2 ampere if you are switching the direction. Okay, so if you are changing the direction, okay, you write the value of current without the minus sign. Okay, and here it's going to be 1.22 ampere, and here it's going to be 0.33 ampere. Okay, now let me go back to the problem statement. What does the problem statement ask us to find? We are asked to find the value of voltage across the current source. So here, you don't know the value of resistance. You only know the value of current that is coming out of this current source, right? But you could see here that these two elements, this current source and the resistor, they are in parallel. So we know the definition of parallel elements. Elements are said to be in parallel if they experience the same potential. So as we could see that these two elements are in parallel, we could say that voltage across 2 ampere current source is equal to the voltage across the 5 ohm resistor. And hence, what is the voltage across 5 ohm resistor? It is going to be 5 into, so here you have two values of current. So plus minus. So this current. So this is entering this point. So it is going to be here plus and here a minus. So it could be seen that here across 5 ohm resistor, we have two currents flowing. One is I3 and the other is I2. I write I3 minus I2 because I3's magnitude is greater than I2. So after solving, we have 5 into 2 minus 1.22 and the final answer, which is voltage across 5 ohm resistor, is 3.89 volt. So this 3.89 volt is the voltage across 2 ampere current source. Voltage across current source is equal to 3.89 volt. So let me again explain. If you have a current source at the periphery, don't worry. Look at the value of current that is coming from the current source. Just equate it to the mesh current. So if this is going to be the mesh current, you could just write I3 is equal to 2 ampere. So let me quickly give you one circuit. So 5 volt. Here you have a 10 ohm resistor, a 5 ohm resistor, a 3 ohm resistor, and here you have a 2 ampere current source. So if you have such a circuit, it could be seen that you have two meshes. So let the mesh currents be I1 and I2. So here you're going to write I2 is the current that is flowing in this mesh. And you could see that here you have 2 ampere. So you could just equate these two because the direction is also going to be the same. So one of the equations is I2 is equal to 2. That's going to be the second equation. First equation is by applying KVL. So to apply KVL, I first assign polarity. So after assigning polarity, I apply KVL to mesh 1. And let me start from this point. So it is plus to minus. So 10 into I1 plus 5 into I1 minus I2. Remember, I am writing the equation for mesh 1 and hence I have to write I1 and then the other current. Sorry, it is here plus. Okay, I1 plus I2 and then I continue. Now I travel from minus to plus and I see 5 volt and I have come back to the point where I started. So this is the first equation. Solving these two equations or by directly substituting the value of 2 here, you could find I1. Okay. So with this, I believe you're all clear with the mesh analysis when you have a current source at the periphery. Kindly watch the next video to be familiar with super mesh and how to do mesh analysis when you have a current source common for two meshes. Thank you.